So in this video, we will be discussing relation and functions. So first of all, ordered pair. Two numbers A and B listed in a specific order and enclosed in a parenthesis, they forms an ordered pair. For example, A, comma B. Now this is an ordered pair. In the ordered pair A, comma B, we call the first member this as the first component and B as the second member or the second component. Now by interchanging the position of component, the ordered pair is changed. So that means if A comma B will not be equals to B comma A. As we have already done ordered pair in the coordinate geometry. Now, in coordinate geometry, the position of a point in a plane is determined by an ordered pair that we know. Now see, for example, if you take like 2 points, 4, 5, 4, 5 and 5, 4. See, they have different positioning in the coordinate geometry. So that, as you see, 4, 5 is not equals to 5, 4. Now, which is same as A, B not equals to B, A. So, 4, 5 not equals to 5, 4. Now, equality of ordered pairs. Equality of ordered pairs. This is a very simple thing. Like if you see, if you write A, B, if suppose this is equals to C, D, then separately A will be equals to C and B will be equals to D. That B will be equals to D. Now just take an example. They are saying find A and B when it is given that A minus 1, B plus 5, this is an ordered pair, is equals to 2, 3. Now these are ordered pairs, you have to find A and B. So by separately doing it, A minus 1 equals 2 and B plus 5 equals 3. So A is 3 and B is minus 2. A is 3 and B is minus 2. That is our answer. Now the Cartesian products of two sets. Let A and B, these are two non-empty sets. Then the Cartesian product of A and B is a set which is denoted by A cross B. So this is the Cartesian product of A cross B. Now it consisting of all the ordered pair A, B such that A belongs to A and B belongs to B. This is the Cartesian product. B belongs to B. So basically this A cross B is equals to, now in bracket we write A, B such that A belongs to A and B belongs to B. So this is the Cartesian product of two sets. Now if there is one more point, if like NA, if suppose NA, you know, remember what is NA? N is the number of elements of set A, is denoted as P, and NB is denoted as Q. So the N of A cross B, N of A cross B, this will be given as P into Q, or N of B cross A is same as PQ. But we should know that A cross B is not equals to B cross A. Now I'm writing this A cross B, so they are equal, but they are not going to be equal. I mean the number of this A cross B, the numbers will be the same, but A cross B is not equals to B cross A. Now for the Cartesian product, we can take an example to understand this. Now suppose A is 1, 3, 5. Now this is A 1, 3, 5, and you take B as 2, comma 3. Okay, now we have to find A cross B and B cross A, and we have to show that A cross B is not equals to B cross A. So see, A cross B will be, now this A cross B, 1 into 2, 1, 2, 1, 3, 3, 2, 3, 3, 5, 2, 5, 3. So this is A cross B. Now for B cross A. So for B cross A, that will be 2, 1, 2, 3, 2, 5, 3, 1, 3, 3, and 3, 5. As you can see in A cross B and B cross A, this is 1, 2, this is 2, 1, 1, 3, similarly this is 3, 1, 3, 2, this is 2, 3. So, as we have discussed before, like 4, 5 is not equals to 5, 4. Hence, A cross B is not equals to B cross. We can take one more example. Suppose if A is 1, 2, 3, B is 3, 4, and C is 4, 5, 6, and C is 4, 5, and 6. Now let's find A cross B union C. Now see, what will be B union C? Let's write B union C first. So B union C will be 3, 4, 5, 6. B union C will be 3, 4, 5, 6. Now A cross B union C. What is A? 1, 2, 3. Yeah, though it will be a big, that's fine. A is actually 1, 2, 3. Now Cartesian product 3, 4, 5, 6. Okay, so this cross this, so that will be 1, 3, 1, 4, 1, 5, 1, 6. Then 2, 3, 2, 4, then 3, 3, 3, 4, 3, 5, 3, 6. So this is what A into B union C. Now similarly we can do for B intersection C. Now suppose you have to find A cross B intersection C. Now B intersection C. What is B intersection C? B intersection C is I think it's just a 4. Yeah. B intersection C is 4. So 1, 2, 3 cross of 4. So 1, 4, 2, 4, 3, 4. So this is A cross B intersection C. Similarly, we can find okay, now just take one more example. Taking the elements like set A as A, B, C only. A okay, now again one more example. Again let A be 1, 2, 3, B as 3, 4 and C as 4, 5, 6. Now we have to find A cross B, then intersection of B cross C. Now what is A cross B? Now write A cross B equals, this is 1, 2, 3 cross 3, 4. So A cross B equals 1, 2, 3 cross 3, 4. So this is, we write 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. Okay, I have A cross B. Now B cross C. B cross C. So this will be 3, 4 cross C is 4, 5, 6. Okay. So B cross C, because we have to write the elements of B first and then C. This is 3, 4, 3, 5, 3, 6, 4, 4, 4, 5, 4, 6. Okay, now the intersection. Intersection means common. Now as you can see from these two, 3, 4 is the only intersection point. So this A cross B intersection B cross C is 3, 4. So hence this A cross C, sorry, A cross B intersection B cross C is 3, 4. Now we can take one more illustration or example. Suppose A, now they have given A cross B, like A cross B is 3, 2, 3, 2, 3, 4, 5, 2 and 5, 4. They have given this. Okay, now A, in this case A cross B is given to you 3, 2, 3, 4, 5, 2, 5, 4. You have to find A and B. Find A and B. Now we know that it's A cross B. So A is what? A is the set of all first coordinates of element A cross B. So A is what? So A is the set of first coordinates of elements A cross B. So basically this is 3 and 5. 3 and 5. And what is B? B is the set of all second coordinates of element of A cross B. So if you take B, B is basically 2, 4. So 2, 4. Hence A is 3, 5. B is 2, 4. Likewise, okay, take one more example. Now let R be the set of all real numbers. Suppose. Now the question is, what does R cross R will represent? Now we know that R cross R will represent, we can take this as X and Y axis. On the X and Y axis. So they represent the set of all coordinates in the point in a two-dimensional space, 2D space. So basically R cross R is what? Is a set of points in a two-dimensional space. Okay, now our next example. It is given that A cross A has 9 elements, 2 of which are -1, 0 and 0, 1. We have to find set A and A cross A. Now, to find the elements of A. Now the two elements are given -1, 0, 0 and 1. So clearly from this we know the elements of A will be -1, 0, 1, because these two elements are given of A cross A. So A is basically -1, 0 and 1. Now we have to find A cross A. So that will be A cross A is -1, 0, 1, cross again -1, 0, 1. So writing the elements, that will be -1, -1, -1, 0, -1, 1. Next will be 0, -1, 0, 0, 0, 1. Then that will be, next will be 1, -1, 1, 0, 1, 1. So this is A cross A. Okay, now there is just one more topic, an ordered triplet. Now in this case 3 numbers ABC is just like an ordered triplets, like 3 numbers ABC listed in a specific order and is enclosed in parenthesis forms an ordered triplet. So this is just an ordered triplet A, B, C. This is an ordered triplet. Similarly, as in case of ordered pair, this one, like if you take an ordered triplet like 1, 2 and 3, okay, that will not be equals to 2, 1, 3, which in turn will not be equal to 3, 2, 1, and etc. Now for like example, like suppose you take just R is a set of all real numbers, as the example we have just discussed before. Now what does R cross R cross R, what does R cross R cross R represents? Now R cross R cross R represents the set of all coordinates of a point now in a 3D space. Now that was, I think, yeah, this was a 2D space, R cross R, because only 2 coordinates, X and Y. This is a 3D space, X, Y and Z. That's why they represents a 3D space. Our next example. It is given that x, y, x square plus y square equals 25, where x, y belongs to whole number. Now it's whole numbers. We have to write this as a set of ordered pairs. Now ordered pairs. Now if we take x equal to 0 and y equals to 5, x equal to 0, y equals to 5. This implies x square plus y square, which is 0 square plus 5 square equals what? 25. Similarly, we can take x as 3, y as 4. What is x square plus y square? Same. So this is 3 square plus 4 square, 25. Taking x as 4, y as 3. What is x square plus y square? 4 square plus 3 square, 16 plus 9, 25. Now x 5, this is 5, y 0. What is x square plus y square? It's 5 square plus 0 square, so which is 25. So now the ordered pair of this will be written as 0, 5, 3, 4, 4, 3, 5, 0.